Okay, this is 6.1 trigonometry. We're going to cover sine, cosine, and tangent for right triangle trig. Basically, we have to have a right triangle in order for this to work. But I want you to pay attention to sine, cosine, and tangent. And this SOHCAHTOA is a mnemonic device to help us memorize what pieces are associated with what. The S would stand for sine, C for cosine, T for tangent. O would be for opposite, H for hypotenuse, and the A would be for adjacent. The way I learned this was some old horse caught a horse taking oats away. It was a long time ago. Still memorized it even today. And this stands for sine is equal to the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. On your cheat sheet, you'll see here that in the area section, we have a trigonometric ratios. So I give it to you on the cheat sheet. Sine of A is equal to the opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. This will become clear when we talk about like a right triangle. We're going to define what each one of these pieces mean. If I'm looking at the sine of A, again, we know that sine talked about opposite over hypotenuse. So I got to look at the angle A and notice that this side over here is opposite of A, and we usually call it lowercase a to denote it's opposite of the point A. So however long this is, and however long the hypotenuse are, that's how we're going to find out what the sine of A really measures. So if we did the cosine of A, it would be the adjacent over hypotenuse. So again, since B is adjacent to this angle A, it's part of the angle that forms it, and then C is the hypotenuse, we would say it's B over C, however long this is and this is. The tangent, again, opposite over adjacent. So I say this is opposite of A. This side over here is adjacent to A. So the tangent of A is opposite over adjacent. Now that we can see all of these different ratios that measure out, we can work on them for each piece. We could also talk about angle B. Opposite of angle B would be side B. This would be the opposite. This would be the adjacent, but that's for a different angle. And we can talk about angle A and angle B when we're talking about right triangle trig. So the SOHCAHTOA, now you know it's sine opposite hypotenuse, cosine adjacent over hypotenuse, tangent opposite over hypotenuse. And we can do this for angle A or for angle B. So if you look at it all as one big picture, you can see where all of these are dealing with angle A. Angle A, angle A, angle A, angle A. So it's the side opposite of angle A over the hypotenuse, side adjacent to angle A over hypotenuse, and side opposite of angle A over the adjacent to A. And this is sine, cosine, and tangent. We're going to talk more about how to do these types of problems. And this one is exactly like a test question or quiz question. So when you retake chapter 9, you're going to want to know how to do this because it's going to be on there. Okay. The question asks us to find the length of EF and the sine, cosine, and tangent of both acute angles for the given triangle. Well, I know that this angle here is acute, and I know angle F is acute. So we're going to do both for angle D and angle F. Now, to find EF, you could do the right triangle Pythagorean theorem, a squared plus b squared equals c squared, or you could notice that on your cheat sheet, there's a Pythagorean triple. Okay, 7, 24, 25. We have the 24, 25. What we don't have is the 7. So I know that EF is 7. Now, when I look at angle D, we're going to draw the picture specifically just for angle D. And we're going to say that 7 is opposite, 25 is the hypotenuse because it's the opposite of the 90-degree angle, and then it leaves 24 to be the adjacent side. All right, so now I've labeled my diagram for the specific angle that I'm talking about. Now with this diagram I've drawn, we're going to plug in this information. So sine of A, or in this case D, is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We'll start plugging our stuff in. For sine, we have opposite over hypotenuse, which would be 7 over 25. Yeah, 7 over 25. Cosine would be adjacent over hypotenuse, which would be 24 over 25. And then tangent would be opposite over adjacent, which would be 7 over 24. So this is how we just found the sine, cosine, and tangent of this triangle for angle D. We're going to use this information later on to do some more cool things, but for right now that's sufficient. Now we're going to redo the triangle again, but now we're looking at angle F. And since 24 is opposite of angle F, we know that this is the opposite side. It's still the hypotenuse, and 7 now becomes the adjacent side. Again, we're going to set up sine, cosine, and tangent, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and now we're going to start plugging stuff in. The hypotenuse is still 25, and the opposite side is 24. The hypotenuse is 25, the adjacent side is now 7, and the opposite side is 24, and the adjacent side is 7. Okay. So we're just plugging in information where it goes. When it says opposite, you put an opposite. When it says adjacent, you put in the adjacent side. When it says hypotenuse, you put in the hypotenuse. And this will be the main bulk of what you're going to be doing for this chapter 6.1. All right, so what is the pattern or relationship between trigonometric ratios for the two acute angles? So notice here at cosine of D, isn't that the same thing as sine of F? And sine of D is the same thing as cosine of F. And then tangent D, that's the reciprocal of tangent F. Just kind of some to notice. Write that out in your own words, however you feel appropriate. Okay, so now it says express sine, cosine, and tangent of angle X. We're going to express it as ratios or fractions. So we're going to label the entire picture according to angle X. And 2 is opposite, 4 is the hypotenuse, and 2 root 3 is the adjacent side. It's helping create the angle X. So once I've marked my diagram, now I can start plugging in my opposite over hypotenuse, which is 2 over 4. Opposite over hypotenuse right here, 2 over 4. And then I can reduce that down and put it up here, 1/2. Now we can do cosine. Let's see, adjacent over hypotenuse. Okay, 2 root 3 over 4. And again, I can reduce this down to be root 3 over 2. That would be 1/2. All right, now the last one says tangent. We're going to do opposite over adjacent. So it's going to be 2 over 2 root 3. Now the 2's cancel. And then we got to rationalize the denominator by multiplying by root 3 over root 3 to get root 3 over 3. And that is the tangent of X, fully reduced, which I will expect you to be able to do as well. Okay, so now we're going to move on to a trig table. Trig tables are very common, and they used to be used way before we ever had calculators that could do them for us instantaneously. They would make a trig table for angles 1 through 360 degrees. Okay, so 360 different values. And then they would put in there and they would do sine, cosine, and tangent of each of those. And they would do it to 4 or 5 decimal places, depends on how accurate you need it to be. So you'll have a full trig table on page 2. But for right now, let's look at cosine 47. I find my 47, and there's my answer. Cosine of 47 is right here. So sine of 8, we find angle 8, we find the sine, and we say it's 0.1392. Tangent of 55, I go to 55, I go to tangent, and there's my answer. Trig tables are nice because they are no calculations. You just find what it means, and you're done. So now it says we're looking for a sine of some angle that comes out to be this big. So I go to sine, and I kind of scroll down until I find the one that matches. Okay, so it matches with here, so my angle is 49 degrees. Now it says I'm looking for 0.088 and a sine value. So here's sine. Well, that's too big, but this one's too small. So I'm somewhere in between 4 and 5. So I just put 4.5, and we'll call it good. I would expect you to be much more accurate than that, and if you did get a decimal, then I would expect you to round to your nearest degree, so it'd be 4 or 5. Just guessing 4.5 is not okay, but for the purposes of this example, we're somewhere between 4 and 5. All right, cosine. Again, I find 99.03 on the cosine list. There it is. And I see that aligns to angle 8, so I put an 8 in. 600 under cosine. 600, ooh, we're really close with this one. So we're technically in between 53 and 54. So you could put down 53.5, or you could round and say, I am closer to 53. And so you could just scribble out the 0.5 and put rounding to 53. We're closer to 53. The tangent. Oh, I find my tangent list. I find 1.2799, and I give 52 degrees. Find 1327. Oh, I don't see it anywhere. So I say I'm here at 1228 and 1405. So we're somewhere in between 7 8 degrees. Or I'd say 7.5. Again, I would expect you to find which one was closer and then round to that angle measure to be more precise. Now, if we're looking to solve for missing pieces of a right triangle problem, we're going to go ahead and simplify the drawing. We're going to say, okay, we're dealing with angle whichever, and label it as opposite, hypotenuse, and adjacent. So that's our steps. We're going to simplify the drawing and label it for one of the angles. And then we're going to identify the quantities that we know and the quantities we want to know. And we're going to determine which one to use, SOHCAHTOA. Which one of those you need to use to solve for your missing piece. Okay, so the want to know. Then you're going to substitute all the known values and solve. I'll show you kind of what that looks like here. I have the angle 70 degrees, and I have the hypotenuse of 75, but I want to know how big D and C are. So we're going to draw a simplified drawing. So we're going to draw opposite, hypotenuse, and adjacent. Now we're going to say, what do I know? I know the hypotenuse is 75 degrees. All right, and we want to know the adjacent is C, and we want to know the D value. We want to know C and D. We know 75. And we also know the angle is 70. So we're identifying kind of what we know and what we need to know. So we're going to look at this and say, I want to be able to use which of these three, sine, cosine, or tangent, will help me find one of these informations, C or D. So right here we see we can use the adjacent part with cosine, and we could find the opposite part with sine. So we're going to substitute those values in for the proper trig ratio, and we'll solve for the unknown. So cosine A is side adjacent over hypotenuse. And so right here we're going to have the A, or the angle that we're using, is 70 degrees, equals C over 75, right? Adjacent over hypotenuse. And when we multiply both sides by 75, we end up with C, or the length of the adjacent side, is 75 times cosine 70. And we could go to a trig table and find out what cosine 70 is, multiply that by 75, and we'd know our value. All right, so now we're going to use the sine for the opposite. And so we plug in our sine equals opposite over hypotenuse, gives us 70 equals D over 75, and we multiply both sides by 75 to end up with the opposite side, D, is 75 times sine 70. And again, I go to the trig table, I find out what sine 70 is, multiply that by 75, and I find my D value. Okay. Now, again, find the value of y to the nearest degree. I like this question. So here's y. 2y, 9.5 is the opposite angle, and hypotenuse is unknown, and then the adjacent side over here is 9. So I know the opposite is 9.5 and the adjacent is 9, and I want to know what angle y is. So which of the three trig ratios uses opposite and adjacent? Well, we look through here, opposite hypotenuse, opposite adjacent. So we're going to use the tangent formula for y. So we're going to plug everything where it goes. Tangent of y is equal to 9.5 over 9. Now, 9.5 over 9, if we did the actual division, it would be 1.0556. So I go find my trig ratio, I find tangent of these two, and it looks like it's closer to 4.47 than it is to 46. So my actual angle for y would be 47 degrees. Now again, you could do 46.5, but we're not going to get that technical, okay? Just figure out which one is closest, and that's your angle. Okay, summarize what you learned in 6.1, and get your worksheets out and work on your worksheets a little bit, and that should be enough.